Welcome back. Today we're going to talk about graphs of rational functions. We've talked previously about how to find asymptotes and x-intercepts, and this is kind of putting it all together. And so as we look to graph rational functions, we're actually going to be looking at what it would take to sketch them, knowing the intercepts and the asymptotes. So let's go ahead and go. Here's the list of how to. Now, if you want to pause here and go ahead and write this list down, I've got some commentary on each of the points, so you can go ahead and pause here, write this down, or you can just write and keep up with me. First of all, we're going to find the y-intercept. Well, the y-intercept is really where x is equal to 0. So to find this, we're going to evaluate f of 0. So just put 0 into the function and find out what comes out, and that's going to be the y-intercept. To find the x-intercept, it's where does the function equals 0. And what that means is basically we find 0 for the denominator. Sorry, the numerator. Right? Because if I've got a fraction, I've got 0 on top, that's going to be where the function's equal to 0. So I'm going to set the numerator equal to 0 and find that out. Vertical asymptotes, we talked about yesterday. That is where the denominator equals 0. And the horizontal asymptotes, that's where we have to compare the degrees of largest exponents on top, and top is going to be n, and bottom, so numerator and denominator, and the bottom was m, and if n is less than m, that's going to give us y equals 0 as an asymptote. If n is equal to m, then we take lead coefficient of the top over lead coefficient of bottom. And that's a fraction that equals y. So y is equal to, like 2 over 3. And 2 over 3 would be the lead coefficient of the top, lead coefficient of the bottom. And if n is bigger than m, there's no asymptote. And that's for horizontal, no horizontal asymptote. And so we're going to plot all those things. Plot the y-intercept, plot the x-intercept, find the vertical asymptotes using that dotted line, find the horizontal asymptotes using that dotted line, and then we're going to peek at the graph. So you're going to need to show all your work to find all of those things, and then you can peek at the graph to sketch the rest. Okay? So let's go ahead and do an example. First one is sketch the graph of g of x is equal to 3 over x minus 2. So the first thing we're going to find is the y-intercept. And that's going to be f of 0. So I got 3 over 0 minus 2, so that's going to give me 3 over minus 2. And so the point is 0 comma negative 3 halves. Second, I'm going to find the x-intercept. And my x-intercept is going to be where the denominator or the numerator equals 0. Well, 3 does not ever equal 0, so there's no x-intercept. See, because I can never have that numerator equal to 0, so it can't exist. Number 3, we're going to find the vertical asymptotes. And that's going to be the denominator is equal to 0. So I'll just set x minus 2 equal to 0. So I add 2, so x equals 2. is a vertical asymptote. And in 4, I'm going to find the horizontal asymptote. And so I'm going to evaluate what my n and m are. The degree of the highest coefficient, or the highest power of x up here is 0. So n is 0, and m is 1. And so n is less than m, which means y equals 0 is a vertical asymptote. And so let's look at what this does to our graph. So I'm going to sketch myself a little coordinate plane here. And if my y-intercept is 0, comma, negative 3 halves, I got to put on a little, some little tick marks here. 3, 1, 2, 3, 1, 2, 3. Okay, so negative 3 halves is negative 1.5. So I'm going to come down here. I go 1.5. So that's my y-intercept. There's no x-intercept, so I did this. This is fine. I got a vertical asymptote at x equals 2, so that's here. Boom, 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 boom. All right? Man, that's a ridiculously straight line. I did a nice job there. All right, and then my horizontal, oops, I miswrote that. You guys probably caught that. Horizontal, because y equals 0, is a horizontal asymptote, so it's going to be along here, and that's kind of tough to see with the black and the red situation, but it's all good. And now we're going to peak. Okay, so I've got a little graphing software up here. You could just as easily use your calculator. And so I've already got this one plugged in. So 3 over x minus 2. And if I graph this, notice right here, I've got an asymptote. Well, on my graph, kind of pull this off to the side, x equals 2 is an asymptote, and y equals 0 is an asymptote. So it kind of goes this way, and there's my 0, negative 1.5. That's my y-intercept, okay? And that comes down this way and up here. And so my graph is going to look like this. Use green. Got to go through my y-intercept. Boom. And right like that. So it's kind of directing itself toward those asymptotes, but it'll never get there, okay? Plot all the things, peak, and sketch. Let's do another one. My next one is f of x equals 2x minus 1 over x. And so first of all, got to find that y-intercept. My y-intercept is f of 0. So I'm going to plug in 0. So 2 times 0 minus 1 over 0. Well, I can't divide by 0. So this is undefined. Well, what does that mean? That means there's no y-intercept, because 0 is not in the domain. So no y-intercept. 2, my x-intercept. And that's going to be where my bottom, nope, sorry, that's going to be where my top is equal to 0. So 2x minus 1 equals 0. And so I got 2x equals 1. So I divide by 2. X equals 1/2. So it's x equals 1/2, comma 0, because it's my y-intercept, or my x-intercept. That's where y equals 0. 3, vertical asymptotes. My vertical asymptote is going to be where I've got 0 in my denominator, and so x equals 0 is my vertical asymptote, because I just have an x on the bottom. And for number 4, I'm going to look at the degrees of my coefficient, so horizontal asymptote. Look at n, and the degree of the highest power is 1 on top, and on bottom the degree of my highest power is 1. So n equals m. So that means I have lead coefficient over lead coefficient. And so in this case, the lead coefficient of my top is 2, the lead coefficient of my bottom is 1, so my horizontal asymptote is at y equals 2, because the degrees of the powers were equal. So when I'm graphing this, I'm going to graph all my parts. No y-intercept. That's easy enough to graph. X-intercept is 1/2 comma 0. I'm going to make my graph a little bit bigger here. 1, 2, and 1, 2, and 1, 2. And so if 1/2 comma 0 is my x-intercept, I gotta put that in there. I've got a vertical asymptote at x equals 0, so that's going to be right here. And my horizontal asymptote is at y equals 2, so it's going to go here. And then I'm going to peek at my graph. And so I'm going to pull up my graph here, have this one graphed already, typed in. And as you can see, I've got an x equals 0 asymptote here and a y equals 2 asymptote. I've got my x-intercept here at 0.5 comma 0, which is what I had, so I got to go in the upper left part and the bottom right part. So it looks something like this. You guys get a bonus, you get sound effects today. Okay, so that's the process of working through these. Let's do one that's a little bit more complicated, but really it's the same 4 steps with that 5th of the peek and sketch. One more example. In this case, f of x is going to be equal to 2 times x squared minus 9 over x squared minus 4. First of all, y-intercepts. My y-intercept is going to be f of 0. So on top I've got 2 times 0 minus 9 over 0 minus 4. So I've got negative 18 over negative 4. If I reduce that by 2 on top and bottom and the negatives cancel, I get 9 over 2. So my y-intercept is 0, comma 9 over 2, which is 0, 4.5. 2, x-intercept. What's going to make my top equal to 0? Well, I've got 2 times x squared minus 9, and I'm setting that equal to 0. Well, what we've done in the past when we had something like this is we try to factor what's in those parentheses, and this is a really great strategy here because we're going to be finding a lot of things that make top 0 or bottom 0, and so you could immediately almost just factor this at the beginning to make your life easier. So in this case, it's a difference of squares, so I've got x plus 3 and x minus 3. And I'm just going to go ahead and do the bottom too because I know that's going to tell me about my vertical asymptotes. And so on bottom I've got x plus 2 and x minus 2. Why did I factor those? Just to give myself a clearer picture of what's going to make it equal to 0. And so really when I'm looking at my x-intercept, I'm evaluating this for what's going to make it equal to 0. Well, this part could be equal to 0 or this part. And so it's x is equal to 3 would make it 0, or x is equal to minus 3 would be equal to 0. So 2 x-intercepts here. Number 3, vertical asymptotes. So I'm looking at what makes my denom 0. And so I've got x minus 2. X plus 2 equal to 0. See how these skills that we've been working on are coming back and they're helping us out with these functions? And so I have x is equal to 2 or x is equal to minus 2. Number 4, horizontal asymptotes. And this is where my comparison comes in. So on top I've got 2, on bottom I've got 2, so 2 is equal to 2, so that means I'm going to make a fraction out of the lead coefficient. So up here, if I was going to distribute this in to find out what that lead coefficient would be, it would be 2, because it would be 2x squared minus 18, and then on bottom it would be 1, so I've got 2 over 1, so y equals 2. Sketchy sketch. 1, 2, 3, 4. Got to sketch all these points on here. See what we got. Y-intercept is 0, 9 halves, so that's 4.5, so 1, 2, 3, 4 and a half. X-intercepts are 3, 1, 2, 3, and negative 3. Vertical asymptote at x equals 2 and x equals minus 2. And also I have an asymptote at y equals 2. Holy cow, got a lot going on here. I've got 6 different parts now. So when I'm looking at my graph here, check out what's going on, turn this one off. So I just put in the top in parentheses, got the bottom here. Look at what happens. I've actually got 3 parts of this graph instead of just 2. And so if you can see here, I've got a horizontal asymptote at 2. These graphs can't touch that. I have a vertical asymptote at 2, vertical asymptote at -2, and then this up here is that 4.5 that I was looking at. All right, and so my curve is going to go like this, upwards this way, but not getting to those asymptotes, and then down this way, and then down this way, and up this way. Okay, there's the sketch of my graph, guys. It's all skills that we've done before, just putting them all together and then peeking to sketch. All right, thanks for watching, and we'll see you next time.